Hello, friends. We need to talk about passwords, and I know what you're thinking, and the answer is yes. I'll tell you why in a minute. But first, let me introduce myself. My name is Adrian Vollmer, and I work as a penetration tester at the German pen testing company SYS. I started in 2015, and I've been specializing on Active Directory networks. My favorite social network is GitHub, but you can find me on Twitter as well. So why do we need to talk? There's been plenty of discussions about passwords already, but they usually don't take the context into account. For example, web services have a very different threat model than Active Directory, because in a web service, while weak passwords aren't exactly desirable, they're not that big of a problem. If a user's password gets compromised, that's not so good for the user, but the platform itself isn't really at risk. Only if it happens at a large scale, business might be affected. But in Active Directory, one single weak password can make the difference between a failed attack and your entire network being held for ransom. There's also a bit of misinformation about passwords, password quality that I want to clear up. And this talk is also coupled with a tool release. It's an open source tool that will help you find the weak points in Active Directory networks when it comes to passwords. And it gives you some new insight on security-related topics in it, which is why I think this talk will be helpful for both pen testers and defenders. All right, let's take a look at situations where weak passwords might be a problem. In my experience, I identified around these 5 points. And by the way, I want to differentiate between brute force attacks and password guessing attacks. Because in brute force attacks, you try every single combination of characters there is up to some fixed length. While in a password guessing attack, you might want to use just a dictionary of words. And in fact, I claim that most password guessing attacks are actually dictionary attacks. No one really uses actually brute force attacks. They're not efficient enough. Okay, so let's take a closer look at each of these 5 situations. I'm just going to summarize in case you don't know all the details about the specific vulnerabilities. All right, so the first one is online password guessing. That's pretty obvious. This means that you simply attempt to log on with each password candidate. Typical tools that do this are Metasploit's SMB login, or if it's in a domain, I recommend you use Cabroot. It's pretty effective. The typical frequency, though, is around 10 per second if there's no lockout threshold. If there's a lockout threshold defined, it's more like 5 per hour. It depends on the threshold. This goes per account, but still, it's the most ineffective method there is. These type of attacks are what should concern you most if you're a web service. But in Active Directory, you also have a couple other attacks that are, I would argue, more important. And obviously here, an attacker can escalate from being an unauthenticated attacker to an authenticated attacker. Right. In the Kerberoast example, this is a very, very popular attack because it's considered a quick win. You only need any Active Directory account to perform it. You can see on the picture what a typical hash would look like. This is actually a Kerberoast ticket. So as a user, you can request a Kerberoast ticket for any other service user with an SPN. And then you can take the ticket and try to crack it offline. It's encrypted with the password of the service user, so you can just try to decrypt it with a bunch of password candidates, and if you get lucky, you get the password. Again, here, typical tools are Impacket or Powersploit that I like to use. And here, the frequency, like the efficacy of the attack is around 10 to the 9 per second. If it's E-type 23, which means it's like RC4 algorithm involved. So that's much, much, much more efficient than an online password guessing attacks. No comparison. And here, the thing is that escalation of privileges happens sometimes because you go from a domain user to another domain user, which might have more privileges than the original user, but it might also have no other privileges. Another example is NTLM authentication. Okay, that's a protocol that's very popular in a lot of services, Windows-related services, and it's a challenge response protocol. Essentially, the server is asking the client to sign something with their secret key, while the secret key is the user's password. Typical tools here are Responder, which also does authentication coercion. But if you're in a suitable position on the network, you can simply use Wireshark or TCP dump or something like this, or some specialized tool like Seth. And then you get a hash like it's on the picture here. And again, you can try to recreate that signature with password candidates. And this way, you can try to crack the password. This is also done offline. The frequency here is around 10 to the 8 per second. And here, in this attack, an unauthenticated attacker, again, you only need the right network precision, goes to either a local user or domain user. One other example that I regularly see on my pen tests are domain cache credentials. These are credentials that provide an offline logon functionality. So imagine you're in a train or something, or in an airplane, and you want to log onto your Windows computer, but obviously the domain controller is not available. So with this, you can still log on to, I don't know, read a Word document or something. And these are stored on the hard drive in the registry. These can be read with Secret Stump or some other tools. There's plenty of them. And there are simply salted hashes with a cost factor. And the cost factor, especially since Windows Vista, is pretty high, so these are really hard to crack. Here we're talking about a frequency of maybe 10 to the 6 per second. And in this case, the escalation of privileges goes from a local admin, you need local admin permissions to read these, to some domain user. Can be a domain admin, can be a regular boring user, can be anything. And these three situations that I just talked about are, in my experience, the top situations where privilege escalation happens in an Active Directory. There's one more hash type that I should mention, and it's the NT hash. That's just how Windows or Active Directory stores the passwords of users. They're either stored in the SAM hive in the registry or on the domain controller in the ntds.did. This one's actually, so it's not that necessary because the cracking is not necessary. You may have heard of the pass the hash technique, because remember when I said the secret key was the password, it's actually the hashed password. So if I know the hash already, I have the secret key, and I usually don't even need to crack it. Tools to get this hash are, again, either Secret Stump or PyPyCats. There's plenty of others too. And these you can crack really, really efficiently with 10 to the 11 tries per second. However, there's a problem with the privilege escalation. To be able to read these, I need to have domain admin credentials already. And then I can, compromise another user? I mean, doesn't really make sense. The same with local accounts. So they're not really useful in the sense of privilege escalation, but they can be useful for something else. I'll tell you why, for what in a minute. But first, here's another slide on, this is an overview of all these hashes I just talked about. I also included the LM hash here. That's a legacy hash. It's not really used anymore because it's really weak. It has such a small password space that you can crack it in a couple of minutes. And by the way, all these frequencies that I told you, the hash rates, the cracking rates, are with respect to one of our machines at SYS, one of our cracking rigs. I put the specs at the bottom of the slide down here. It has 4 GeForce graphics cards. It's a pretty beefy machine, but still, an attacker could buy the same hardware. It's not that special. So the reason why I included these hashes is because I had an idea for a benchmark. All right, so enough about these basics. Most of you know these probably already. Let's get to some more interesting things. I noticed that customers love being rated and ranked. They always ask, how did we do? Are we average? Are we below average? Are we above average? It's kind of a tough question because you have to rely on your gut feeling. It depends on the experience of the pen tester. And there's no obvious way to somehow collect the experience of all my colleagues, so I can, give a little bit more objective answer. It's completely subjective. So I thought maybe I can do at least one area where I can make a really objective response to this. And the idea was this. Many pen testers do this already after a pen test. They gain domain admin rights, they take all the hashes, they try to crack as many as possible, and then they do a little bit of analysis. But I thought this can be done in a more structured way. And my idea was that we choose a fixed word list and a fixed rule set that stays always the same, and then we can make some concrete statements about the quality. You know, if I always have the same boundary conditions and I build a corpus of all these results, then I can tell my customer, well, I cracked such and such percentage of your accounts, and this makes you better than whatever customers that we have, like 80% or something. But I want to stress that we only store non-identifying statistical results in this database. We don't store any passwords or anything like that. It's just statistics. And this database is what I call the Better Passwords project. For this, I wrote a tool called Hashcat, and the workflow goes like this. So first, you become domain admin. This should be easy, right? Second, you retrieve all the hashes. I recommend secrets dump. Third, you give the dump to Hashcat helper, which uses Hashcat under the hood to crack all these hashes. Then you take the result, give it back to Hashcat helper, and let it do some analytics. Okay, so these are the hashes. This is the result from step 3. And you generate a JSON report. In step 5, you submit the JSON report to the database. And in step 6, you print the statistics of this particular account if you already have enough data in the database. Also, a little hint, if you use the flag user status of secrets dump, then you will have information about whether the account has been deactivated or not. It's kind of important because if you don't do this and say you find 200 accounts with a blank password, you tell the customer, I found 200 accounts with a blank password. The customer then says, well, these are all deactivated accounts, so it doesn't really matter. Then you check and you say, oh, you're right, and that's just not really helpful to anyone. So it's important that we remove these beforehand. And this is what Hashcat helper does in the analytics, right? So first of all, it removes deactivated accounts and computer accounts that may be in the file, because those would just distort the result. And then we determine a couple of quantities. First of all, the number of cracked passwords. Also, it reports the number of occurrences where the username equals the password. It also counts non-empty LM hashes. So that's the LM hash of the empty string. This is important for interpreting the quantity in step 1. Because remember, I can crack any LM hash. It's in a couple of minutes. So even if you had an excellent average password quality, but you still stored the LM hashes, then I can still crack 100% of all the passwords, even if they're perfectly secure. So this is important because, it helps you interpret this first quantity. Next, we also have accounts that have a blank passwords, which shouldn't exist. We have password clusters, and by clusters I mean groups of accounts that all use the same password. If you're into graph theory, then you might notice that we should actually call these clicks because they're all related to each other. But since every click is also a cluster, I might as well call them clusters. And Hashcat helper also yields the top 10 passwords and top 10 base words. Where by base word, I mean sort of a normalized password. We try to remove all these little transformations that humans tend to apply to their passwords. So we remove numbers and special characters from the beginning and the end of the password. We normalize capitalization and maybe remove leet speak replacements. It's not perfect, it can't be perfect, but it works pretty well. It's well enough. All right, and these quantities are what we store in the database for each customer. Nothing more. Obviously, the top 10 passwords are not stored in there. And this is what a typical result will look like. So in this case, we have something like over 4,000 accounts. Some of them are computer accounts, some are deactivated. Those are removed, and we're left with around 2,500. And then we crack, whatever, 35%. We have no accounts where username equals password, no with non-empty LM hashes, and so on. And this is what a typical result for one customer looks like. This is, well, obviously a fictional example of the top 10 passwords and top 10 base words. In this case, one of the quantities that we also track is the largest base word clusters, so this would correspond to init right here. This is actually what we see a lot. So it's a fictional example, but it's pretty typical in the sense that we very often see an initial password that the customer is using or has been using. Often they tell me, we haven't been using those for 3 years, but I still find hundreds of accounts that are using an initial password. We also find the company name, location name, seasons, months, first names, and maybe some favorite passwords of some admin. Sometimes there's one admin who has a favorite password, and you'll find this all over the place. And then on the right-hand side, you find the base words. If you look at Troopers, for example, you have 20 here and 6 down there. They're kind of similar and have the same base word, so you have 26 right here. For Workshop, for example, you don't have anything on the left-hand side, but you have 20 occurrences on the right-hand side. Sometimes it's because a customer chooses passwords like Workshop 01, Workshop 02, and so on. Okay. And now the thing with the database. Okay, in the Better Passwords project, we can put this into context. Again, if you look at the cracked passwords, we have, let's say, this customer has 35%. This is the first column here. But the mean value of all customers might be 54%, and this is actually the real number. So the second column, this is real data. So we can say this customer is already a lot better than the mean. And in the third column, we have the standard deviation. So we can even say that this customer is even better than, is better by more than one standard deviation in terms of cracked passwords. And this means it's in the 88th percentile. Okay, so this is the fourth column. That's the percentile. It can be read as it's better than 88% of all other entries that we have in the database. And basically, you want these values in the fourth column to be as high as possible. So higher is better, while in the first column, lower is better, except for the average password length, right? We can visualize this. So here you can see a Kivia diagram or radar chart, spider chart, whatever we call it. And it has all these quantities that I talked about and shows you on one glance in which area the customer should put some effort in. All right. So again, this is the percentile. So you want to be, in a perfect world, you want to be at 100. So you want to have this colored area to be as large as possible. I still owe you some more details about our attack. The concrete word list that I chose, and it's a choice, you can choose any other. It's just that I chose the CrackStation word list and hashes.org. In CrackStations, you have some guy who compiled a list of all leaks and breaches and Wikipedia in all languages, many books from the Gutenberg project, and so on. And it's basically the mother of all word lists. We have in total over 2 billion entries in this word list. It's 26 gigabyte. So it's quite something. And as a rule set, every password candidate is transformed according to some rules. As a rule set, I chose one rule. And this is pretty interesting because there's a group that took a look at all the existing rule sets that are out there, figured out which rules are the most effective ones, so which rules yield the most password cracks, and compiled a list, a new list. I built a very effective rule set. I can tell that this one works really, really well. And in combination, this word list with this rule set yields over 100 trillion candidates. On our cracking rig, this takes around 7 hours. Okay, so I can start this at in the afternoon, I come back the next morning, and this is done. And notice that this is, in the big O notation, constant in time. Okay, at least it doesn't depend on the length of the password lists. It only depends on the list of the word list. So if you have secrets dump output from several domains, or because maybe you had several pen tests in a week, it makes sense to crack them simultaneously, and Hashcat actually takes several positional arguments to do this. All right, so to summarize, the result from testing 44 organizations over the last year, with a total of over 167,000 accounts, is that we crack on average 55%, plus or minus 17%. If we assume this was a normal distribution, it would look something like this. This is the comparison of the actual distribution to the normal distribution. You can see some outliers on the left-hand tail. But yeah, that's around what this is what 41 organizations look like. But wait, there's more. Hashcat Helper also has some couple other features that a coworker of mine suggested. For example, it also finds passwords in the have I been pwned database. We already had this in earlier talks. This is something that's really popular. So you download this database, and a Hashcat helper can tell you which accounts have a password that's already been known publicly. And you can also use Bloodhound. We all love Bloodhound here. So you can use Cypher queries to filter the accounts. So you can generate the same reports, but say only for accounts that are Kerberoastable, or only accounts that are domain admins, or only accounts that are in high-value groups, or only accounts that contain ADM underscore, or something like this in their name. And thirdly, Hashcat Helper can also add new edges to your Bloodhound database. It's an edge type called same password, and this enables you to generate graphics like this. All right, so you can visualize the clusters of accounts that all use the same password. And this is also this is from real data. Okay, so this is pretty typical that we see something like this. And here, just as a quick comment, these are now actual clusters. Again, they should be clicks, but if I wanted to make these clicks, I would need to add so many edges that Bloodhound is quickly overwhelmed, so I'm just going to stick with clusters here. Or else, you know, for example, obviously, if this account has the same password as this one, and this one the same password as that one, then we would also need one edge here. But this is way more faster, and it works just as well. It also allows us to show specific clusters. I wrote a couple custom queries for this, and sadly, due to the way Bloodhound works, we need to edit the raw query every now and then. So down here you can see you may have to edit this one, so enable query debug mode. You just click on a query and edit this one down here. Here I wrote ADM underscore. So now you see all admins that are using the same password as their low privileged account. Okay, and this is something that would otherwise be hidden. It's also very difficult to enforce on a technical level. And this is something that you can then show the customer and makes it very clear what the problem is. It also enables you to find paths like this. Okay. So this is a path from some lowly privileged account to on the very left to some high-value group like domain admins on the very right. And it's only possible because here we have one occurrence of accounts using the same password, and again here. Okay. Obviously, to generate these kind of graphs, you already need to have domain admin permission, so it's not going to help you escalate your privileges in a pen test, but it might help you to create these pretty pictures and tell the customer that this is a problem and maybe show up some more escalation paths after you already found one. Okay, so now that we have this new insight, what do we do with it? First, I want to discuss some common countermeasures. I just actually had this conversation downstairs with someone who said, well, can't we just create some policy for this? I mean, you can increase minimum length and you can complexity, but this password here, password 1, 2, 3, exclamation mark, is both long and complex, but it's still weak. It will be cracked in a second. It's also not going to take care of legacy accounts. There may be one very, very powerful account that has been created 15 years ago by a guy who's retired 5 years ago, who has a 3-letter password, but has essentially domain admin permissions. And you're not going to find this by changing the password policy. Another thing that people like to do is install password filters, which isn't a bad idea in itself either. But so, for example, it checks for banned words every time a new password is set. Azure AD does this out of the box. In Active Directory on-premise, you would have to install some third-party modules. You can also check with have I been pwned. But again, it's only proactive. You know, this only works for new passwords that have been set. It doesn't work for old passwords. And sometimes very old accounts also don't have expiring passwords. So those might just exist and pose a security risk to the network. These password filters may also disallow perfectly fine passwords. I know this from experience. Sometimes you have very, very strict filters and they say your password contains 3 letters that appear on a keyboard pattern or something, so I can't allow this password even though it's 20 generated characters. This is just frustrating. It also does not find password reuse. So the pictures I just showed you, you cannot find with these measures. And I mean, even the largest filter doesn't even have 120 trillion entries, and I just showed you by combining the right word list with the right rule set, I can generate 120 trillion password candidates. So what should we do then? I propose the following. So first, we shouldn't care too much about, say, Greg and Janet in accounting with their low privilege accounts. An attacker shouldn't be able to do much with them anyway. You know, assume breach is a thing in the industry. Some people already assume that the attacker might have a lowly privileged account, and if you think about it, ransomware usually comes in through a word macro or something like that, and they already do have an account. So you need to make sure that this is safe anyway. Just use a block list. Again, it doesn't hurt. Use multi-factor authentication for everything that's exposed on the internet, and use a sensible lockout threshold. Okay, it would be unwise to have no lockout threshold at all. Instead, you should focus on administrative accounts and service accounts, because you should have a tiered model anyway. At least every admin should have one privileged account and one unprivileged account, which means that administrative accounts and service accounts don't really log onto workstations. No one logs on in the morning with an administrator account, which means that they can use secure passwords. And by secure passwords, I mean randomly generated passwords. All right, there's no excuses. You can simply put them into a password manager, and you don't have to remember them. And anyway, there's this saying, with great responsibility comes, with great power comes great responsibility. So any account that has admin privileges on at least one machine must have a secure password. Also, don't forget about password reuse between tiered accounts. So if you're using the Microsoft tier model and your admins already have several accounts, you need to make sure to tell them that password reuse between those accounts is bad. There's been more than one situation where I, as a pen tester, was able to escalate the domain admin privileges only because at least one admin was using the same password for their, say, tier 1 account and their tier 0 account. This is, again, hard to enforce on a technical level, but if you can, so if you're allowed, you could run a secret stump and hashcat helper yourself, and then you will find exactly these types of security risks. Also, I guess, don't use Windows and Active Directory, because this really could have done a lot better, but I know this is a moot point. Okay, now it's time for your question. Let me answer the first one. Hashcat helper is on GitHub since yesterday. It's free and open source. Thank you very much.
I got a question. Why do you use the password list? What about rainbow tables instead of the password lists? What brings you to password cracking lists?
Yeah, so rainbow tables were usually used for the LM hashes because they can only be 7 characters long, and this is still feasible to have rainbow tables for that. Because it's, I don't know, a couple hundred gigabytes or so, but as I said, the LM hashes are cracked so quickly, I think it takes 4 minutes. There's really no point to keep hundreds of gigabytes around. And for longer passwords, it doesn't make sense again to have rainbow tables.
Any other questions?
Maybe more of a side comment. You mentioned that Azure AD or out of the box does these password tests on weak passwords. That's actually also available as a client integration as an agent integration onto the domain controllers on-prem.
Yeah,
Just as a side note, if you have Azure AD with proper licenses, that's actually quite low-hanging fruit for
All right. Yeah,
all
thank you.
these changing passwords at least.
Right, good comment.
Okay. If there are no other questions, thank you, Adrian.
Have you seen any correlation between the results on your quality testing and the password policies that have been implemented, or is it too small of a number for tests to say something like that?
Well, there's a little bit of a correlation. So you can also generate 2 or 3 more charts that I haven't shown here that show you, and it's a histogram of the password length. And if you have a minimum password length of, say, 10 or so, then you will find like a step, right? That there's maybe a few passwords that still have less than 10 passwords, legacy passwords, but that's usually what it looks like. But if you're asking about the correlation to the amount of cracked passwords, I don't know, I need to check. I think that's a good idea, thanks. There's also another idea that's floating in my mind, and some people have suggested, is to find a correlation between, let's say industry branches that we also take into account. Is this a bank? Is this like an automotive company or something? So this might be an opportunity for future work. I'm not sure if you have enough statistics for each of those, but it's something that we might do in the future.
Have you considered maybe removing the start passwords, for example? Because I mean, you're focusing on the live user base in the end. You want to give the customer feedback on what is actually the users and the service accounts that are in place, that are worked with, what is their password quality, and maybe just a second version of the report with all the start passwords, for example, removed, or with the expired accounts removed, something like that. Sorry. I know that you removed the logged out accounts, but maybe that could be in addition to that.
Yeah, so that would be probably really easy. Everything that's in the Bloodhound database you can easily do, because Cypher queries as a filter are already supported. So yeah. Any other questions?
Hello. First of all, thanks for the presentation. One question: do you only use your on-prem crack station, or do you use like a cloud service?
No, we
we
exclusively use our on-prem crack station due to data protection.
Okay, thank you.
I mean, it would be really nice. Sometimes I really wish we could just buy some cracking time on Amazon or something, but we don't want to do that because these are customer passwords and they shouldn't leave our systems.
Okay, thank you, Adrian.
Thank you.